Good morning to all my dear students. We have started our learning process from the circles, and we have finished circles, most important LAQs, and we have also completed parabola yesterday, most important LAQs, and some problems I gave, one problem I gave as homework. Okay. As in the yesterday's class, I told you to be on time. And one more thing, today we are going to deal with the integration. Two LAQs come from integration chapter. So the most expected problem of integration, today we are going to deal, two LAQs come from integration. So be careful and understand each and every step clearly. Okay. If possible, keep the pencils with you so that what my explanation you can able to write at the time only. So first little bit I will give you what is today's our topic. For example, if we are having integration of ax plus b and ax square plus bx plus c, this form of integration linear quadratic. Okay. Or if this come in square root, then also linear inside this is quadratic. Okay. So whenever the problem comes linear with quadratic form, linear by quadratic form, at the time, just we have certain working rule to follow. That is, this linear, we have to equate in this form like ax plus b, linear quadratic. Okay. First, linear is equal to a d by dx of quadratic polynomial plus b. These a and b are constants. Okay. First derivative of the quadratic polynomial, you have to equate it with the numerator. So remember, and then we need to integrate the remaining process of the solution, content integration. Okay. So just for the first step, you remember that whenever the problem comes linear and quadratic, linear by quadratic, linear under root quadratic, at the time you have to just equate linear in this form. Okay. And then we have different types of integration, means depends on the formula, which form it takes. Okay. So working rule of linear with quadratic, linear by quadratic, or linear followed by quadratic square root and root. This is the working rule for the first step. Okay. You remember this, then we will move for the our problem. This is the working rule. Integration, most important problem, evaluate the integral, evaluate just integral 6x plus 5 root over 6 minus 2x square plus x into dx. Okay. Evaluate the integral 6x plus 5 root over 6 minus 2x square plus x into dx. This is our problem. Now look at how we have to solve it. Okay. First, linear, just don't see the root, see inside, it is a quadratic. Okay. So we have to first equate the linear according to that form. That just now I have said you what is that form. So solution, given that what is given to us, 6x plus 5 integral of 6x plus 5 into root over 6 minus 2x square plus x into dx. This is given to us. According to working rule, we have to equate linear, okay, in that form, which I have just now I have said you. So consider 6x plus 5 is equal to a d by dx of quadratic polynomial, that is 6 minus 2x square plus x plus b. Okay. Now, this I can write a d by dx of constant is 0. D by dx of minus 2x square, minus 2 is constant. D by dx of x square is 2x. So this complete term minus 2x square, when you apply the derivative, it's become minus 4x. And d by dx of x is plus 1. Okay. This you can write 1 minus 4x. 1 minus 4x plus b as it is. So this is 6x plus 5. This equation in next step we have to use. So just I'm making it, marking it. Okay. This is our equation first. Now, comparing respective coefficients means comparing the x coefficient in LHS and RHS with respect to constant, and again with respect to coefficients, and again comparing the constant terms. What we are getting, this I'm writing here. Comparing coefficients of respective terms. Okay. See here, in LHS, we are having x coefficient is 6. In RHS, this is a constant, leave it. What is the x coefficient? Minus 4 into a, that is minus 4a. Okay. So 2 3s are, 2 2s are, get cancelled. Now what we are having? This multiplication comes, it will become division. So minus 3 by 2 is equal to a, or you can write a is equal to minus 3 by 2. Okay. This is the first. We have got a value. Now comparing the constant terms, what we are saying, look at here. In LHS, we are having 5 as a constant. Okay. Is equal to, here constant is a into 1 is a plus b. A plus b. Okay. As we are having the a value minus 3 by 2, just write a is equal to minus 3 by 2 plus b. Bring this minus 3 by 2 this side. So it will be 5 plus 3 by 2 is equal to b. Simplify it. 2 5 are 10 plus 3 13, 13 by 2. So I can write 13 by 2 is equal to b, or you can write b is equal to 13 by 2. B is equal to 13 by 2. Okay. So we have got the values of a as minus 3 by 2 and b as 13 by 2. Okay. Now from equation 1, we will substitute these values in equation 1. Okay. So from equation 1, what is equation 1? 6x plus 5 is equal to a in the bracket 1 minus 4x plus b. So just write the a value. What is a value? Minus 3 by 2. So this is minus 3 by 2, 1 minus 4x plus b. B value is 13 by 2. 13 by 2. So from in this problem, on the place of 6x plus 5, we can write this particular values that we have got for 6x plus 5. Okay. So now take this integral, given integral, that is integral of 6x plus 5 into root over 6 minus 2x square plus x into dx. Okay, this I am taking this complete value. Okay, on the place of 6x plus 5, I can write minus 3 by 2, 1 minus 4x plus 13 by 2. Okay, so integral minus 3 by 2, 1 minus 4x plus 13 by 2. Okay, and the next term keep as it is. The next term is keeping as it is. That is root over 6 minus 2x square plus x into dx. Okay, just on the place of this linear polynomial 6x plus 5, I have written this from here to here. Brackets are very, very important in integration. So 6x plus 5 got this form, and the next term keep it as it is. Okay, now coming to the first, we will multiply the first term with this and the next term with this. Just in another way, another words, just I am separating. Okay, how? Look at here. Minus 3 by 2 is a constant, keep it outside. Integral of 1 minus 4x into 1 minus 4x into this complete, that is root over 6 minus 2x square plus x into dx. This is the first term. Okay, now the next term is plus 13 by 2 integral root over 6 minus 2x square plus x into dx. Okay, this is the next term we have got. Okay, look at here carefully. This is first derivative of this expression, right? When you apply d by dx of this particular term inside term, you will get this. So it's nothing but f dash of x. If it is f of x, this is f dash of x. So what is the formula we are having? Look at here. I'm writing the formula here. Okay. So integration of f dash of x root over f of x into dx. Okay. This complete from here to here, it is in this form only. If you apply the derivative d by dx of for this function, you will get f dash of x only here only. Okay. What is the formula for that? The formula is given that it's equal to 2 by 3 in the bracket f of x whole power 3 by 2. Okay. This I'm telling about the first term. Okay. So now I can write according to that formula for these particular steps. This I can write minus 3 by 2 integral, because this complete takes that form, I'm directly writing into 2 by 3 f of x. Okay. Root f of x, I have to write f of x power 3 by 2. So what is f of x? 6 minus 2x plus x whole power 3 by 2. Okay. Again, close the bracket. Okay. So now these three, these two get cancelled. For this, right now I'm keeping it as it is, plus 13 by 2 integral root over 6 minus 2x square plus x into dx. Okay. Now simplify it. What we are getting? Minus in the bracket 6 minus 2x plus x whole power 3 by 2. If you simplify it, you will get this form. Okay. Now, what about the simplification of this particular term? Integral root over 6 minus 2x square plus x into dx. Okay. What to do? Okay. Just look at the right hand side, how I am simplifying that particular steps. Okay. Look at here. I'm going to rough it. Okay. we have this rough column. I'm going to erase. What we are having? 6 minus 2x square plus x. Okay, it is followed by square root. Afterwards, we will use that. See here, first we will arrange this equation, this expression in a particular way. That is minus 2x square plus x plus 6. Okay. Now, from this, if I take minus 2 common, so minus 2 if I take common, x square minus x by 2 minus 3. If you take this term inside the bracket, minus 2 into x square, minus 2x square, minus into minus plus 2 to get cancelled, x as it is, minus into minus plus 2 3 is the 6. Right. Okay. This particular expression, I want to convert in an algebraic identity. That is a minus b whole square. Okay. How? Look at here. Minus 2. This is as a square. Minus 2 I'm taking from my side. This particular minus x by 2, I'm converting in some other terms. When I simplify that terms, I should get minus x by 2 only. So minus 2 into x into 1 by 4. If you absorb this, 2 1 the 2 2 the get cancel, minus x by 2 only you will get. Okay. This is completing square method. So minus x by 2, I can convert minus 2 into x into 1 by 4. So a square minus 2ab. This is the taking the place for b. So just I am adding and subtracting 1 by 4. 1 by 4 square minus 1 by 4 square. These terms 1 by 4 square minus 1 by 4 square, adding and subtracting from my side in order to get a minus b whole square till these terms. Okay, then this minus 3 as it is. Okay. So now this I can write minus 2 a square minus 2ab plus b square. It's a minus b whole square. That is x on the place of a minus as it is 1 by b is 1 by 4 square. Okay. Okay. Now minus 1 by 4 square, that is 1 by 16 minus 3. Okay. This minus 3 till here it is as it is. Now simplifying. So minus 2 in the bracket x minus 1 by 4 square minus 1 minus 16 3 is 48 by 16. So this minus 2 x minus 1 by 4 square minus 49 by 16. Okay. This 49 by 16 I can write minus 2 x minus 1 by 4 square minus 7 by 4 square. Right? Okay. If you take this minus sign inside the bracket, these terms will be interchange their positions. So I can write this as 2 in the bracket. 7 by 4 will come first, minus of x minus 1 by 4 whole square. Okay. So 6 minus 2 x square plus x got this form. I can write root over 6 minus 2x square plus x is equal to root over 2 in the bracket 7 by 4 square, take a big bracket also, minus x minus 1 by 4 square. Okay. This is these terms we have simplified here in this way. So instead of writing this term, I can convert this term into that term. After that, I will get the formula for these terms. Okay. So check the all step from the from here to here, how I have converted by using the completing square method. This particular term, how I have converted. Okay. You just check it. Everything is clear. So now we have to use these terms here. Okay. So what I'm getting here? Plus 13 by 2 integral root over 6 minus 2x square plus x into dx. I can write as 2 in the bracket 7 by 4 square minus x minus 1 by 4 square into dx. Okay. These terms again we have to use. Okay, this should come in inside the root. Okay. Now from this term, this value I'm taking outside. That is, when I want to take this outside means it becomes root 2. So I can write minus 6 minus 2x plus x whole power 3 by 2 plus 13 root 2 by 2. Just this root 2 I have took out and the remaining term as it is. Integral of root over 7 by 4 square minus of x minus 1 by 4 square into dx. This 13 root 2 by 2 for complete terms. Okay. So now, what is this formula? Root integral root over a square minus x square is equal to what? Yeah. Shall I rub this?
Yes, sir.
Very, very important problem. This part have you understood? Because in the next step I have to use it. That's why I'm asking.
Sir.
Am I audible clearly?
Yes, sir.
What is the formula of integral root over a square minus x square? Integration have a lot of formulas. Okay. Integration of root over a square minus x square into dx is equal to x by 2 root over a square minus x square plus a square by 2 into sin inverse of x by a plus c. Right? Integral of root over a square minus x square into dx is equal to x by 2 root over a square minus x square plus a square by 2 sin inverse x by a plus c. Okay. Now, on the place of a square, we are having 7 by 4 square. So it is 7 by 4 is on the place of a minus x square. On the place of x square, we are having x minus 1 by 4 square. Okay. So according to that formula, I'm simplifying this. The next step I'm writing here. This is the formula. Okay. From here, our continuation is here. So minus of 6x, 6 minus 2x plus x whole power 3 by 2 as it is plus 13 root 2 by 2 as it is. Okay. On the place of that, this is a big term. Where to write? Shall I rub the first column? It is not sufficient place here. So I think I have to ref.
Okay, sir.
Root over a square minus x square. According to the formula, we have to expand it. So this takes the form minus of 6 minus 2x plus x whole power 3 by 2 as it is, plus 13 root 2 by 2, 13 root 2 by 2. Now take a big bracket. Brackets are very important. Now x by 2. This complete term is x, okay, by 2 from the formula. So I have to write x minus 1 by 4 by 2, x by 2, root over a square minus x square, root over a square minus x square as it is. That is 7 by 4 square minus x minus 1 by 4 square. Okay, so x by 2 root over a square minus x square is completed, plus, okay, plus a square by 2. See here, a square, okay, 7 square is 49, 4 square is 16 by 2. Look at here, a square by 2. So 7 square is 49, 4 square is 16, 16 to the 32. In this form, I am writing. Got it? So here I can write a square by 2. Directly I am writing as 49 by 32. Okay? 49 by 32. Now, sin inverse of x by a. That is x minus 1 by 4 by a. 7 by 4. Okay? A plus c we will use afterwards. Okay. So now according to the formula, each and every term we have written in this simplification form. Okay. So the next step, just simplifying it, minus of 6 minus 2x plus x whole power 3 by 2 plus 13 root 2 by 2, 4 into x, 4x minus 1, in denominator 4, 4 to the 8. And this term as it is, root over 7 by 4 square minus x minus 1 by 4 square. Okay. Here also we will simplify here what we are getting, plus 49 by 32 sine inverse of 4x minus 1 by 4. Just I am writing 7. 7 by 4 and this 4 will get cancelled. Okay. Now, this 13 root 2 by 2 is for the first term as well as for the second term. Okay. So now just see what we are getting. See here, what clearly, please observe 8 to the 16. Okay. 8 to the 16. So I'm writing minus 6 minus 2x plus x whole power 3 by 2 plus 13 by 16. Okay. I am taking this term for the first term inside the bracket. So 13 by 2 8 the 16. Again 4x minus 1 as it is. This root 2 I am writing with this term. I can write root 2 into 7 by 4 square minus x minus 1 by 4 square. Okay. Once again, I am telling 2 8s are 16, 13 as it is, 4x minus 1 as it is. This root 2 I have written with this. Okay. Clear? So close this bracket. Now 13 root 2, 13 into 49. How much? 13 into 49? I think 13 into 49 is 637. 13 into 49. 13 into 49. Yeah, 637. Okay. So 13 into 49 is plus 637 root 2 by 2 into 32. Okay. 2 into 32. Listen clearly. This 2 into 32. This 2 I can write as root 2 into root 2 and this 32 as it is. So 1 root 2 get cancelled. In denominator you will get 32 root 2. Okay. So this complete terms become 637 by 32 root 2. Hope you understood how I have converted that. And remaining terms as it is, sine inverse of 4x minus 1 by 7. Okay. Now, look at here. Square root of 2, 7 by 4 square minus of x minus 1 by 4 square. What I can write for on this place? This complete term I can write, right? Yes. So, this I can write minus 6 minus 2x plus x whole power 3 by 2 plus 13 by 16 again 4x minus 1 and this complete term. Okay, this complete term from here I can write as root over 6 minus 2x square plus x. 6 minus 2x square plus x. Okay. Now plus 637 by 32 root 2 sine inverse of 4x minus 1 by 7 plus c. Therefore, how such a big solution practice? Therefore, what is the problem? Therefore, integral of 6x plus 5 into root over 6 minus 2x square plus x into dx is equal to minus of 6 minus 2x plus x whole power 3 by 2 plus 13 by 16 in the bracket 4x minus 1 root over 6 minus 2x square plus x plus 637 by 32 root 2 sine inverse of 4x minus 1 by 7 plus c. This is our result. Please check it. From all the steps, where we have to use the substitution form for particular terms, you observe and practice. Similar problem I'm going to give you as homework one. From these two problems, one problem definitely will come in your exams. This is the one problem. One example problem is there. I'm going to give you that also. The same method, same concept, you apply on that. Okay. So please check it once again. Okay. One problem I'm giving you as homework. Just I have to ref it. Yeah. One problem as I'm giving similar to the above problem. Okay. This problem you have to write. You have to practice. Homework problem. Then we will go for the another most important 7 marks problem. This is a homework problem. Evaluate integral 3x minus 2 root over 2x square minus x plus 1 into dx. The same concept that you have learned just now, apply on that, you will get the solution. Okay. Now we are going to deal after this. We are going to deal one of the most important problem of 7 marks that is repeated many times and hope expecting can be repeated this time also. Okay. So I'm writing that problem. This is homework problem for you. That problem and this problem, and one problem will come. Okay. So now another most important problem of 7 marks. Find integral dx by 3 cos x plus 4 sin x plus 6. Okay. Find the integral value of integral dx by 3 cos x plus 4 sin x plus 6. Okay. Fine. What this function gives you? Find integral of dx by 3 cos x plus 4 sin x plus 6. Okay. So look at here how to solve this. Solution, given that integral, I can write the same term as 1 by 3 cos x plus 4 sin x plus 6 into dx. This is given to us. Remember, whenever problems comes, integral a by integral dx by a plus b cos x or integral dx by something a sin x plus b into dx or integral 1 by r dx a cos x plus b sin x plus c into dx. Whenever the denominator takes any of this form, okay, at the time we have to use substitution method. The substitution method's values you have to remember how we are using here. Okay. So if the problem, this problem repeated 7 times, okay, from the previous years, our search says that this particular problem has been repeated for 7 times, expecting this time also it will come. Okay. So observe the denominator. If the denominator is in the form of any of these form, a plus b cos x or a plus b sin x or a sin x plus b or a sin x plus b cos x plus c into dx, any of this form, you have to use substitution method. Okay. Compared to previous problem, this problem is much easy. Okay. So now, if this is in that form, because of that form, just we have to use let or put cos x is equal to 1 minus t square by 1 plus t square, sin x is equal to 2t by 1 plus t square, okay, and tan x by 2 is equal to t, okay. From here, we have to find dx and dt also. So these are the substitutions that you have to remember, okay. So now I have tan x by 2 is equal to t. Just differentiate with respect to x.
Sir,
This,
board is not clear, sir.
sorry,
Board is not clear, sir.
once again,
Board clear గా లేదు, sir.
board is not clear.
Ha, sir.
Oh my God. See here, if you have textbook, this is on page number 228.
Okay, sir.
Second problem. This particular problem repeated many times. And the previous problem that I have solved on the board, please that problem. Okay. One lengthy solution we have done on the board. One I gave as homework, and this is the third one, LAQ. You find the videos on YouTube, SDIF, free coaching supply. Okay.
Okay, sir.
Now it is right.
Ha, sir.
Okay, ma'am. So now look at here. This is in the form of a cos x plus b sin x plus constant, or just a plus b sin x, or a plus b cos x, or a sin x plus b cos x plus constant. Any of that form, we have to use substitutions method. Okay. So cos x 1 minus t square by 1 plus t square, sin x 2t by 1 plus t square, and tan x by 2 is equal to t. Usually we represent tan x only, but now for the some purpose, I have to use tan x by 2 is equal to t. Okay. This particular term, we have to differentiate with respect to x. d by x of tan x is? What is? Secant square x. That is secant square x by 2 into inner derivative of x by 2 is 1 by 2 into dx is equal to dt. This I am writing here also. So 1 by 2 secant square x by 2 into dx is equal to dt. Okay. After differentiation of tan x by 2, we have got that form. Just writing this term by using these all substitutions values. What we are getting, let us check. First, integral of, you can equate this as I also. If you want, you can equate. So no need to write again and again, just you can equate with the I. Okay. Just I have to simplify, that's why I'm writing here. 1 by 3 cos x plus 4 sin x plus 6. Okay. This particular term I'm writing as, look at here, this is given to us into dx. Okay. Just this particular term I'm writing as integral, multiplying the numerator with half secant square x by 2 and also dividing the same term here. 3 cos x plus 4 sin x plus 6 into half secant square x by 2 into dx as it is. Okay, into dx as it is. Look at here, half secant square x by 2 into dx. This complete numerator with dx, it's dt, right? And these two terms are in multiplication. This 1 by 2 I can send to the numerator. Okay, so it takes the form as like this. Integral, this complete terms is dt, half secant square x by 2 is dt. This comes here, it will be 2 into dt by 3. Cos x, what I can write? Into 1 minus t square by 1 plus t square I can write, plus 4 sin x plus 4 sin x I can write 2t by 1 plus t square, 2t by 1 plus t square plus 6 as it is, close this big bracket. Brackets are very important. Now, this 1 by 2 I have sent to the numerator. Okay. Now, secant square x by 2. Look at here. We know that secant square theta minus tan square theta is equal to 1. So, secant square theta, I can write 1 plus tan square theta, right? Okay. So, secant square x by 2, I can write 1 plus tan square x by 2. This I can write as 1 plus t square, as we are having tan x by 2 as t. So, tan square x by 2 is t square. So, this complete conversion I am using here. Okay. So, now here I can write secant square x by 2, I can write 1 plus t square. Okay. Clear? Now we will simplify it. What we are having? Integral 3 into 1, 3, 2 by 3 1 the 3 minus 3 t, 3 t square. When you bring 1 plus t square for this particular term, so this term and this term cancel for the first term. So nothing in numerator, plus 4 to the 8 t, 1 plus t square t, 1 plus t square, 1 plus t square get cancelled. So for the second term also nothing in denominator, plus 6 1 the 6 plus 6 t square, 6 plus 6 t square into dt. Okay. Now simplifying this, what we are getting? I can write integral 2 by minus 3t square plus 6t square is plus 3t square. 6t square minus 3t square is 3t square plus 8t plus 6 plus 3, 9 into dt. Okay. Finally, after simplification, we have got 3t square plus 8t plus 9. Now, we have to change this particular term into some another terms in order to get a proper form of formula of integration. Okay, so I am applying completing square method on this particular term. How? Look at here. We are having 3t square plus 8t plus 9. Okay, see here. If I take 3 common, what I am getting? T square plus 8 by 3t plus 3. Okay. 3 into t square, 3t square, 3 get cancelled, 8t as it is, 3 is the 9, right? So I have to convert it into the algebraic identity, that is a plus b whole square. So t square, that is a square, See here, this 8 by 3 I'm writing 2 into t into 4 by 3. 2 4 the 8 by 3 into t, same term you will get. Okay. 2ab, satisfying algebraic condition and simplification form give the same term here. Okay. So this particular 4 by 3, I have to add, I have to subtract in order to get the form of identity. So add in subtracting 4 by 3 square minus 4 by 3 square plus 3 as it is. So now a square plus 2ab plus b square. I can write this as 3 in the bracket t plus 4 by 3 square, a plus b whole square. Now simplify this. 4 square is 16, 3 square is 9, that is minus 16 by 9 plus 3. So 9 3 is 27, 27 minus 16 is 11, 11 by 9 plus 11. Okay, so you will get 3 in the bracket t plus 4 by 3 square plus 11 by 9. Okay, this 11 by 9 I can write as 3 t plus 4 by 3 square plus root over 11 by 3 whole square. Okay. So by using the completing square method on the place that is denominator, I can use this complete term. Okay. This is the procedure method concept that you need to apply here. Okay. So now this I can write as integral 2 by 3. Okay. That is the complete term. T plus 4 by 3 square plus, take a big bracket because this 3 is for all, plus root 11 by 3 square into dt. Okay. These 3 for the entire brackets. Okay. These 2 by 3 take out. Okay. So this you can write 2 by 3 integral 1 by t plus 4 by 3 whole square, t plus 4 by 3 square plus root 11 by 3 square into dt. Now, this is what is the form of integral 1 by a x square plus a square into dx? Anyone? Nobody? Just think. Integration of integration of 1 by x square plus a square. Yes. This you can write 2 by 3. Just I'm writing the formula where I have to write. Check these all steps. Is there any uh, any kind of confusion? Please ask. This is the just abbreviated form of that denominator. Okay. Ask. This also we can ref. Here I am writing the formula. Integration of 1 by x square plus a square or a square plus x square. x square plus a square into dx is equal to 1 by a tan inverse of x by a. Okay, this is the formula that you have to remember. Okay, so according to the formula, this x square plus a square into dt, what I can write? Okay, just moving from here. So this is equal to 2 by 3, 1 by a, 1 by root 11 by 3. Root 11 by 3, I can write 3 by root 11 as it is. Okay. And tan inverse of x by a. What is x? X, this complete term. T plus 4 by 3 a. A is root 11 by 3. Okay. Plus the s arbitrary constant, we include it. So 3 get cancelled. You will get 2 by root 11 tan inverse of 3 into t, 3t plus 4 by 3 divided by root 11 by 3. 3 get cancelled. So on the place of t, what we can write? 2 by root 11 tan inverse of 3t plus 4. Oh, sorry. On the place of t, we can write tan x by 2. Tan x by 2 plus 4 by root 11 plus c. Therefore, integral of dx by 3 cos x plus 4 sin x plus 6 is equal to 2 by root 11 tan inverse of 3 tan x by 2 plus 4 divided by root 11 plus c. Very, very, very important for problem. Okay. So practice all the problems that we are solving in the class, and the problem which I'm giving is homework. This practice will come to you in the form of your success. So please follow these all formulas and follow the procedure that we are showing to you. Hope this will get by practicing and understanding these all things. Hope you will get your success. Okay. So thank you for today for attending the class and understanding the concept of integration. Okay. Thank you.